Have you ever heard of a neutron star? These are some of the most fascinating objects in all of space. Put it simply, it is a really dense object formed at the end of a star's life when gravity's power ends up putting so much force onto the protons and electrons at the star's core. They fuse together to make neutrons. In this video, we will explore the life cycle of these giants and explain some of their properties. Stick around and find out more. So, to actually understand how neutron stars form, we should first understand how stars form. Stars form by massive collections of gas collapsing under gravity and starting a nuclear reaction that powers the star and releases light. These stars fuse hydrogen together to produce energy. Eventually, they use up all their hydrogen and begin to fuse other elements. This process continues until iron, which absorbs more energy than it releases. The star slowly goes to the end of its life before dying with a passion in a supernova. Sometimes this supernova leaves a neutron star behind. So, quickly recap. Eventually the star collapses under the force of its gravity, and the intense conditions create an extremely dense area of neutrons. The neutron stars are very small considering their average mass is about 1.4 times our Sun at roughly 15 kilometers wide. If you actually think about it, that's really not that much. Let's now talk about their properties. Due to their insane amounts of mass and exceptionally high densities, they have an incredibly strong gravitational field surrounding them. They also exhibit an incredibly strong magnetic field around them due to the intense currents going through them. Another characteristic property of them are their massive jets shooting material at it close to the speed of light. These massive jets sometimes align with our Earth, and we can pick up their signals as they emit radio waves and electromagnetic radiation. We call them pulsars. So, to quickly recap, neutron stars are relatively small celestial objects with an exceptionally high density and really intense magnetic and gravitational field strength that form after a supernova. I am now going to walk you through many examples and some cool facts about them, starting off with a phenomena called a kilonova. Simply, a kilonova is basically where two neutron stars that are orbiting each other eventually collide into each other and blast off their energy. The intense conditions created by them are believed to be the source of some of the heavier elements in the universe, such as gold and platinum. Now, to end off, let's go over some neutron stars. Very few we can actually identify, so I'll just go over the ones that have actually been named instead of just some random numbers. A famous example is the Black Widow pulsar, which is a neutron star in the Milky Way that is found in a binary system, which is basically one consisting of two objects orbiting each other and rotates exceptionally fast. It was discovered in 1988, and we estimate it to be about 6,500 light years away. The image is an artist's impression of it. Next is the Crab pulsar, located in the Crab Nebula, that I talked about in my nebula video. It is quite a young neutron star, and it was the result of a supernova called SN 1054, because people on Earth would have seen it in 1054, and it was the first neutron star connected to a supernova remnant. Finally is the Vela pulsar, an X-ray and gamma emitting pulsar located in the constellation of Vela. I'm not sure if I'm saying that right. Anyway, its creation is linked to the Vela supernova that happened roughly 12,000 years ago. Anyway, that's it for today. If you have any feedback, please drop it in the comments, as it would be greatly appreciated. And if you enjoyed, please like and subscribe to my channel. Thank you.